Welcome, everyone. Sorry we're running a little bit late, so without further ado, please welcome Steve Chu, Energy Secretary, and Eric. Steve, just by way of introduction, is a physicist. He got his degree at Berkeley, I think. Not that there's anything wrong with that. Was a professor at Stanford, did a lot of great things there, including, for example, founding the BioX department. Then went back to Berkeley, drove a lot of the advanced energy research at Lawrence Berkeley Labs, was a vocal advocate for renewable energy research, and now is our Secretary of Energy. Has received lots of prizes, including one where a guy in a Scandinavian accent calls you at 4 a.m. in the morning. So we're very, very happy to have Steve here. So please welcome Steve.
Thank you.
All right, thank you.
Thank you, Mr. Secretary, for joining us. It's great to have a Nobel Prize-winning physicist in our government. And I think we have, is it Christina Johnson's here?
Yes.
She's your Undersecretary
of Energy. Yes, please, Christina, stand up.
Yes, thank you very much. What I thought we could do is spend a couple of questions and then go to the audience. It's always very interesting at Google. What did you announce today?
We announced the first tranche of funding for a new way of funding energy research called ARPA-E. It's a way that we wanted to identify ideas that could potentially be home runs. Very high risk. We expect a lot of them will fail, but we're hoping that some of them will succeed. The response was enormous in the first funding opportunity. Over 3,700 applications were received. We're giving out 37, 1%. The way we did the review is something quite remarkable. We needed and really wanted the best reviewers in the country. So I simply sent a letter out to the presidents of the major research universities, the heads of the major engineering and scientific societies, and said, give us names of your best reviewers. We just want the names. So they gave us a whole bunch of names, and we began to call them up. And surprisingly, in some areas, 23, 40% of the reviewers, people said, we'll do it. We'll do it for free. 4.2 person years of reviews in a month. And it's a way of doing business that we hope to actually inculcate the rest of the Department of Energy, that it's simply one's patriotic duty in this time and age that our best engineering and scientific talent is willing to step up and review these things. Because yes, we're investing a lot of money, but we have to make sure that the money is invested in the
right way. You wrote an influential paper about setting up this whole ARPA-E even before you were in federal government. Can you highlight a couple that are examples of this approach?
Well, okay, so what we wanted to do, and this was coming out of this report called Rising Above the Gathering Storm that Norm Morgenstein chaired, and this committee that I was privileged to be on recommended that the U.S. government set up ARPA-E, and then I was thrust as the spokesman for the committee.
This is what happens when you write the memo. You become in charge.
Yeah, something bad like that happens. You know, to try to sell it to the House and to the Senate. And
what's an example of some of the awards that you've done today that, that sort of show this path?
Okay, so let me give you one example. When you are breathing, you metabolize sugars and create carbon dioxide in your cells. Your body has to get the carbon dioxide out of your cells. If you look at the way we capture carbon dioxide today in a power plant, it's an amine solution. The kinetics are very good. The carbon dioxide is absorbed onto this material, but you have to pay a huge energy penalty in order to get the carbon dioxide off of the material. And that's part of the large costs of today's technology. But there's an existence proof of something that works in nature. We can get the carbon dioxide from your cells into the bloodstream, and you exhale it, and there's no energy penalty. It's all at body temperature. There's an enzyme that makes the reaction, the ability of carbon dioxide to dissolve in your bloodstream, 10,000 to 1,000,000 times faster than it would without the enzyme. And so, so there's an existence proof that there are better ways to capture and transport carbon dioxide. The great thing about this is one of the proposals is let's try not to use the enzyme, because the enzyme is very fragile, and in a flue gas environment it would be poisoned immediately. But let's use organic chemistry to synthesize a similar structure that would be more robust, that would greatly decrease the energy penalty. No, if this works, it'll transform the cost of carbon capture.
You also have chosen some winners in battery technology, right. Solar. Can you right. highlight a couple of those?
Okay, in battery technology, if you look at today's batteries, they're, one is used to paying electricity at 10 to 14 cents a kilowatt hour. But if you look at how much you're willing to pay for to store energy, it turns out it's about $3,000 for your lithium-ion batteries in your laptop computers. Right now, for bigger energy storage on the scale of 1 megawatt hour worth of energy storage or above, or and also you want 1 megawatt of power, we actually don't have batteries that do this. There are commercial sodium-ion batteries, vanadium batteries, but the cost is of scale $1,000 a kilowatt hour.
Yeah, so it's prohibitive.
And it's prohibitive. You can't use that. So if you have solar cells on rooftops, you use the electricity or you lose it. So we're investing in something that has, instead of an anode, a cathode, and an electrolyte, the metal, it's a liquid battery, so that the anode, for example, could be magnesium. The electrolyte is a solution of magnesium ions and antimony ions in a salt, a chloride salt, and the cathode is antimony. You charge the battery up. What happens is that the electrolyte solution, they separate out, and you actually physically grow a liquid layer on the positive terminal and physically grow a liquid layer in the negative terminal that's pure metal, okay? And a little thin electrolyte. It separates by itself because there are different densities, so it's just floating. So it can be a swimming pool size. It can scale up enormously. And then when you discharge, you turn it back into the electrolyte. A radical new idea. There's a possibility the cost can come down by more than an order of magnitude. It was inspired by aluminum production, which is where you take an enormous amount of electricity and turn a solution of aluminum into solid aluminum. But you're also evolving carbon dioxide. And they said, well, let's figure out how to do it so two metals can take place.
Do the same thing.
And so this is one example of something that could be a true home run.
Now, since you've been secretary, you've been arguing pretty strongly publicly about the need for what you call a second industrial revolution.
Right.
And by that, I take it you're covering all of energy. You want to take us through the math, the next 20 or 30 years, what it's going to take. What does this industrial revolution look like?
Okay, so if you look at the scale of what has to be done, it's quite staggering. Start with renewables. We're roughly 3% of renewables, excluding hydropower. Hydropower is about 6%. Once you start, and wind is on a good footing. It's near getting close to cost parity, except it doesn't include the transmission and storage costs. So let me give you an example. The Department of Energy operates Bonneville Power Administration. It's 20% wind, 80% hydro. Even at 20% wind, they have to maintain spinning reserves, which are actually hot boilers, fueled by fossil fuel, up and hot, because the wind can stop blowing at a moment's notice, and you need instant on energy. So we need something to deal with transmission over larger distances and energy storage, hence batteries or pumped hydro storage and other things like that. We need a transmission line, a distribution system that can port the energy over hundreds or really thousands of miles. So that has to be developed concurrently as we gear up the renewables. The solar technologies are okay, but they're still pretty expensive. On a box top rooftop, like a Costco, it's $4.50 per kilowatt installed. Higher on a home, the cost of the modules is going now down below $1 So it's the balance of the system that has to come way down. So we're trying to figure out, and so we, at $1 a kilowatt in complete installed price, we will see a revolution.
Absolutely. Now, do you need the president and you have argued for a cost for carbon of some
Yes.
form today, cap and trade.
Yes.
Play that out. What happens? How do we establish it? How do we change it?
Well, we established it with legislation. So there's a bill that has gone out of the House, the Waxman-Markey bill. There's other forms that are being debated in the Senate. There are different jurisdictions, so the Energy Committee has.
Well, there's a Boxer Kerry bill.
And there's a Boxer Kerry bill that is going to be taken up, and the hearings start tomorrow morning. Where on that one, I would say that.
In fact, I think you're testifying tomorrow on that subject, aren't you?
Yes. So unfortunately, after here, I have to give a talk at Livermore. There's an event tonight in San Francisco, and then the red eye, and so I'll be testifying with 3 hours sleep. I hope I do okay. But anyway, we need a comprehensive bill that that sets the ground rules so it promotes energy efficiency, that it promotes renewable energy. It also we need to figure out how to clean up our coal. We need to stimulate the start of a nuclear industry again. And most importantly, we need a limit on carbon, a cap, and something that ratchets down.
So the skeptics, of which, long-term skeptics, of which I'm one, believe that while the U.S. will eventually get our act together with your great leadership, Europe will get its act together because it's very progressive on these things, maybe even China. The sum of the world will never be able to operate a cap-and-trade system that's effective because you always have the problem of rogue actors, rogue states, and so forth. Copenhagen, of course, this is a major attempt at addressing that. Are you optimistic about all of this over a 20 or 30-year period? There's evidence, as you know, that there are triggers where there are negative cycles that can occur that are very, very difficult to reverse. And there are people, including Mr. Hansen, who argue that these triggers could be met within the next 20 years.
So you're talking about these very nonlinear triggers,
the
tipping points. Yeah, I think there is a danger. Those, because they're nonlinear, they could have a runaway effect. But let's go back to the question about, how do you actually monitor and how do you actually enforce something? The world has to get on a carbon diet. It has to be this decade, in my opinion. So the good news is, the Department of Energy is talking with DOD, with NOAA, with others, that we think satellite detection of point sources like a coal plant is well within the realm of technical viability, so that in a satellite you can actually look down and measure the carbon emission using infrared spectroscopy of a particular coal plant.
Well, in fact, people are using Google Earth to monitor deforestation and the issues of the rainforest and so forth. So we already have a model there.
Right. So with the infrared spectroscopy, we think that you will have the technology that will say, okay, your country is emitting. I mean, it's going to be a little harder with the carbon coming from soils and things like that. It's much more dispersed. But point emissions, we think, will be detectable.
So two final questions, and then I want to go to the audience. Let's talk a little bit about coal itself, carbon capture and sequestration. The technology is still fundamentally in its debugging form. There are not large plants that are operational. What is the outlook for CCS and the issue? As you know, it's so tempting to burn coal, either legally or illegally, because there's so much of it, especially in big industrial countries.
So, coal is very abundant. It's in fact so abundant, there's not that much serious looking for coal. The United States has 25% of the known coal reserves in the world. And you look, what are the other countries? Well, Russia, India, China, and Australia. That's 3/4 of the coal reserves. India and China probably will not turn their back on coal. And quite frankly, the United States probably will not turn its back. So we have to develop a technology that can use it in a clean way. If we don't, this would be very tragic. So now where are we? If you look at today's processes, there's two approaches. Either you separate out the carbon dioxide before you combust, or you separate it after. We have to do both. It's very important that we develop after burning technologies, because between now and when we actually get viable solutions that are going to be routinely deployed, where on best case could be 8 or 10 years from today, there will be more coal plants around the world being built. A coal plant will cost $1 billion to $2 billion in today's market. That's a lot of money, and you're going to use it for 60 years. The technology to capture coal after you, the carbon dioxide after you burn coal is expensive. In today's technology, of course, amine capture, it will increase the cost of generating electricity by about 80%. That is too high. The developing countries and the United States will not go for that. So we are looking at, we have a roadmap of how to get down to 20-25%, okay, which is tolerable. And in addition to that, there are some really new high-risk ideas that are out there that can even be better. So this is part of what we have to do.
And it's part of, I suspect, your agenda at Energy.
Right.
Now, in the same vein, the Department of Energy controls much of the nuclear world in the United States, as you know. And you are famously in favor of restarting nuclear as a power generating source. My observation about nuclear was that every plant was different. The human factors were a disaster. Whenever the alarms go off, all the alarms go off at once. These accidents are very, very serious and obviously can be used to fearmonger and so forth. So a credible argument says that we haven't yet figured out a way to build in volume nuclear reactors for production. Another set of arguments has to do with the safety inherent with the way in which we do nuclear power. And then another set of arguments has to do with nuclear fuel storage, which, as far as I can tell, is an unsolved problem. So without those as your obstacles, why are you calling for an increase, if you will, from the current 0 rate of production of nuclear power plants?
Because I think all of them are solvable, and many of them have been solved. Safety, the newer designs of nuclear reactors are going towards what we call passively safe. If you lose totally passively safe is the goal, you lose complete control of the reactor, and gravity feeds down into the cooling, so you don't need...
Literally, the water is above, not below, and the water drains and puts the...
That's correct. Or the design is such that it will never actually get in a meltdown condition. So there's the safety issue. The waste issue is something that, again, I think is solvable.
Have you visited Yucca Mountain yet?
No, I haven't visited Yucca Mountain. But the whole Yucca Mountain history, sadly, was very heavily politicized. But what we're going to do is we're going to start a blue ribbon panel that will look at the entire nuclear question all over again from scratch, based on what we know today versus what we knew 25 years ago. We're using less than 1% of the energy content of the uranium we mine. And so there's depleted uranium that's just building up. And out of the 5% enriched uranium, we use 4% of that, but the rest of it is now reactor waste. And so we would like to design things so that we can go much more significantly into that just 1%. It wouldn't be great if we can use 30, 40%. Wouldn't it be great if you can have a way to burn down the long-lived actinides, to reduce the problem from a hundreds of thousands of year storage problem to a few hundred-year problem, and greatly reduce the waste. So there are a bunch of new ideas out there that we want to try. This is a long-term R&D program. But in the meantime, I'm pretty confident we can get there, but we do want to start because it's, quite frankly, it's carbon-free baseload power, and eventually, yes, we want to get to renewables, but remember, sometimes the wind stops blowing, the sun stops shining. So given that, and if you look at where we are in today's coal technology and where we are in today's nuclear technology,
you would favor fixing these nuclear issues. My final question is really a personal question. You are the first scientist in this job. You are the senior scientist in the Obama administration. You're in a government that today is highly polarized among the various political parties. You suffer or love, depending on your point of view, the way the founding fathers set up Congress and funding and so forth and so on. What's it like to be the senior scientist in our government?
Well, it's It's fun in a macabre sort of way. I don't think the people in Congress treat me like your average cabinet member.
It's because you know something that's really tough, right? you can't be sort of blustered by false facts.
Well, that's one thing that I do know. No, the other cabinet members are quite knowledgeable, but let me go on the record saying that. But many of the things we deal with are completely nonpartisan in my mind. Yeah. And the other thing is that a lot of what the Department of Energy does is very intimately science and technology based. We're the biggest funder of the physical sciences in the United States. In fact, our funding has given out and supported the work of more Nobel laureates than any other funding agency in the world. And we've trained more future Nobel laureates probably than most universities. Berkeley Lab, where I came from, we trained in graduate students, postdocs, young career scientists, over 30 young people that went on to get their Nobel Prize. So this is something that is very much part of the business of the Department of Energy. The other thing is, between John Holgren and I and Jane Lubchenco and a few others, we actually know something about the climate issues and have looked at it deeply. And we know something about the facts having to do with the climate issue, which is refreshing. So I think Congress is the people in Congress that I've talked to, even the people against it, they're willing to listen to me. And I've said, look, if you want, come to my office, I'll go to your office, and I'll talk about why we think what we think is happening. And so that, at least, is a positive way of going about this. I think the President has made it very clear that science, it plays such an intimate role on the decisions the country has to make in the coming years. And so he really wants to put science back on the agenda.
Yes, and I know this as well. Let's get some questions from the audience. Yes,
Hi,
sir.
thank you. Here, question around a lot of the talk around carbon dioxide is capturing it and sequestering it, and I wonder either with the grants that were just announced or long-term plans, if there's any plan to actually do something useful with that carbon dioxide and produce value out of it. Considering the model we see with plants, it should be feasible.
There are a couple of ideas. There are strains of algae being bred that can thrive on much higher concentrations of carbon dioxide that can be used to make biofuels, particularly diesel. Already, a number of groups have altered the genomes of the algae so that they make excessive lipids, and so to assess that the lipids are actually ejected out of the organism and they float to the top. They can be skimmed off in a continuous process to make diesel fuel. Enhanced oil recovery, of course, is already being used, but there are a number of ideas like that to actually, I think the economic use of the carbon dioxide is something that would promote its adaptation much more quickly.
So are you not promoting sequestration?
We have to do all the things, is the point. We don't know what's really going to work and take hold, but I do know this, that several dozen things have to happen. This is an enormous problem.
Go ahead. Thank you. Yes.
So I'm encouraged by your discussion of restarting nuclear. Are you considering, or any of the grants considering, a thorium cycle, which seems to have the potential of reduced environmental footprint and byproducts? We're
looking at thorium, but not in the RPE grants, because it doesn't have, RPE is quick hit, in a couple of years. Is the private sector going to pick it up, or is it so innovative that perhaps other funding agencies can pick it up? But certainly we're looking at more advanced development within the normal nuclear engineering programs of the Department of Energy, including thorium. The Soviet Union is actually looking very hard at thorium as well.
Thank you.
Go ahead.
Russia. Showing my age.
Go ahead.
I've heard that transmission development concerns hinder development of wind and solar power. Could you talk about what the issues are and what, if all, you're doing about that, either in terms of aligning incentives or sponsoring research?
Well, the major issue is siting. There's two issues. One is siting. Whenever you want to build a new transmission line, that's all fine, but nobody wants it in their backyard.
How might we incentivize those people that are resistant?
That's a great question, and I like your way of thinking. I think we have to do some cost allocation and actually provide financial inducements to allow people to put it in their backyard, and that will go a long way towards helping. There's a lot of money out there sloshing around in terms of the energy. In primary energy, it's over $1 trillion business, and so we're considering ways of either getting a small fee on transmission use of energy to be used to help in siting. There's also cost allocations. Who's going to actually pay for the transmission line is an issue. But to your point, I think it would be very helpful if there was a financial incentive so that people can say, I'm willing to have this transmission line in my backyard.
And a federal renewable portfolio standard is part of that. A lot of the lines get caught up between the states because the PUCs disagree and things like that. It takes 7 to 10 years to get one of these things built, which is a real issue for this market.
One of the things that is actually happening is that when you build a transmission line, we need to build them so you have this tower and you get the siding, but the business will only take a certain amount of power. And so in the past, what people have been doing is fairly short-sighted. They'll build the transmission line they need. And so we're trying to get now in place ability to say, let's look 50 years ahead. Build a bigger tower, put up one line, maybe with a loan we'll help you build a bigger tower, and then put on the same tower other lines as needed. So you don't have the United States being crisscrossed with these transmission lines, and you don't have, the siting has already been done. The approval has already been done. And we're also so between Interior, FERC, US Ag, us, and CEQ, environmental quality, we're trying to, within our agencies, trying to help get this process going. So we've been meeting regularly, including the principals, the secretary level, to help that.
Go ahead.
So the previous gentleman already asked my question about thorium, but we've seen a number of exciting talks recently on various energy sources, and one was on focus fusion, and I was wondering if there's any money going into that.
Onto what type of fusion?
Focus fusion?
This is where the ions are being focused and channeled to get fusion. Is that what we're talking about?
I believe so. It's using the instabilities of the plasma against itself, essentially.
We are looking at fusion. There are certainly the Department of Energy is investing in ITER, but going beyond ITER, we are looking at fusion. We're also looking at fusion-fission hybrids, so that you use fusion as the source of energetic neutrons, 14 MeV neutrons, that can burn down the long-lived actinides and actually create out of U-238 plutonium. But we're also trying to figure out how to do this in the same reactor so that you actually use more of the fuel, so that you get a bigger burn down of the fuel. Instead of burning 4% of the fuel, they burn 50%. So all these ideas are in play. New technologies, so-called wave reactor technology. You start with a plug of 15–20% enriched uranium, and you can start with even depleted U-238. You try to capture all the neutrons, so those neutrons turn U-238 into plutonium. Then it's burned down, and the neutrons then go on further and turn more of the U-238 into plutonium, which then is burned down. And after you're done with this, you use 30% of the fuel. The outer layer you haven't done. The inner core, you've burned down a lot of it. You scrape out the outer layer, you reprocess it. So there are a number of technologies that we're trying to figure out how to do. The fusion is tough. Pure fusion is still very, very tough. And so it looked a little bit, I know that Google was interested in doing one of those things. I looked a little bit at it, got some of the experts at Lawrence Berkeley Lab to look at it. It's not, but we'll see.
Okay.
Go ahead.
You mentioned that you can track illegal carbon activity using either satellite or a different technology. who, in your opinion, can effectively police the illegal activity once it's found? Is it the U.S. or is it the UN?
It would have to be some international body that does this. But the first order of business is you've got to measure the carbon emissions in countries, and that will give us. It's like anything else. It's like arms control. It's once you're able to verify things. It gives everybody much more ease that you can get an international agreement. And so part of the technology of developing the ability to measure carbon emissions worldwide in non-invasive ways, like with satellite, is part of, it's going to be a very key part of the international agreements.
Well, and those agreements, there will ultimately be a set of treaties that really will be enforceable, is the only way I think it can happen.
But you know, having said that, I mean, there are always going to be some bad actors and rogue nations. I mean, on Saturday I was at the Monterey Bay Aquarium was celebrating their 25th anniversary, and Jane Lubchenco of NOAA and me and Federico Pena, who was actually was raised or grew up in the Monterey Bay area, were talking about these issues, and a very, very similar thing having to do with the overfishing of the world's oceans. And so there's a common resource. In the case of the climate issue, it's the earth, it's the carbon dioxide in the atmosphere. In case of fishing, it's the fish in the ocean. 90% of the big fish of the ocean are now gone because of overfishing. And there are always rogue nations that could try to get more than their fair share, but more and more countries are caught on to the fact that unless you come together and do this, if every nation for itself and overfish, we'll have our continuing disaster. So now, having said that, there is a convention, an international treaty for a responsible use of the ocean. The United States has not signed it.
Yep. And as far as I know, we're the only signatory.
Yeah, we're the only developed country has not signed it.
We're going to have to pick up the pace here, so go ahead.
Hi. So it seems like in the U.S. we spend an awful lot of energy in production of commodity corn. So I was wondering, like, ethanol is this, very politically difficult issue. I was wondering how closely you work with the Department of Agriculture, and if there are any initiatives that are coming to.
Well, what we would like to do is transition as quickly as we can away from corn to crops and even agricultural waste that makes more energy sense, more carbon dioxide sense. And so as far as the Department of Energy is concerned, we're investing very heavily in biotechnology research that will allow us to use agricultural waste like wheat straw. Half the corn stover can be used, the other has to be plowed back into the fields. Lumber waste. Some of the RPE work that we're funding is to that end, and there's many other programs that we are funding. So it's research. We now have organisms that can convert simple sugars into diesel-like and gasoline-like fuel, but the yield is low. And so it's all about making it economically competitive. I'm actually optimistic on that one. I think in 5-10 years we'll have something.
Okay, go ahead.
Maybe less.
You mentioned that something that is appealing about nuclear is that it supplies baseload energy. I'm curious, what are your thoughts on geothermal, and how does its promise compare to nuclear?
It's a possibility. Geothermal is also baseload. We need to bring the costs of drilling way down, of deep drilling. But there are two types of geothermal. One type is ready to go today, and it's local geothermal. If you build a new house and there's enough of a plot of land, which is not much, and you put in a little trench of plastic pipe, a heat pump and water exchange using that plastic pipe in your backyard is fantastic. It's much cheaper so if you're in the Midwest where you have to air condition in the summer and you have to heat in the winter, it's much more efficient to do it, and will pay for itself in probably less than 10 years of investment. So that local geothermal is there, it works, it's today, okay? And for buildings, and even for people who live near bodies of water. If you go down into a lake or something at certain depths, you can, there's a heat reservoir that's really pretty good. The other geothermal that you're talking about, and especially the enhanced geothermal that is a possibility, we're pushing. It's a possibility. It's not there yet. We're well aware of studies like the MIT study, and we're trying to accelerate that, including actually developing better technologies so you can drill faster.
So, thank you.
Thanks.
So we've now sort of running out of time. So what I want to do is I want each of you to suggest the subject of your question, and we will ask the Secretary to answer them all at once. So go ahead. What's the subject of your question?
The subject is like cradle to grave and how you incorporate the cost of actually creating the materials, like creating solar panels or wind, et cetera.
So all the things about manufacturing.
The environmental costs of that.
Go ahead. What's the subject of your question?
Similar subject. How can we reduce the amount of energy in manufacturing? Should we reduce consumption or make appliances, say, reconfigurable and reprogrammable?
Okay. Your question.
And ARPA-E is just a great model for the government taking a big step to step in where the private sector can't yet. And I was wondering if you can spread that to other departments of the government, like transportation, education, and encourage the cabinet members to do the same.
Okay, your subject of your question.
Subject is, the U.S. has operated 2 molten salt reactors in the past. You were asked about this in your confirmation hearing. You said corrosion was a big issue. There's been some material science work in that area, and currently we're spending about $400,000 a year on this, which is enough for one guy at MIT to read what France and the Czech Republic are doing. We're planning to change that.
Okay, and the subject of your question.
And what types of innovations, partnerships would you like to see from Google in coming years?
Perfect.
Cradle to grave, I think companies are beginning to do that. We need to develop systematic ways of evaluating what cradle to grave carbon and energy costs are. I think that's an important part of it, because it goes to having a deeper appreciation of the full processes of what the carbon costs would be. Manufacturing, especially anything that can reduce the carbon footprint of manufacturing has to be done. Some of the companies in the United States who have been very serious about that have been so successful that it's now part of their business. They can export ways of reducing carbon footprints. Dow Chemical and DuPont Chemical, for example, are 2 companies, especially Dow, which still is in the commodities plastic business. It's another part of their business. They're going to teach other chemical companies how to save money. I'm trying to remember what
molten salt.
Molten salt. I didn't know it was only, what was it, $40,000, $400,000. Well, all I can say is in the upcoming budgets, we're putting a lot more money for nuclear research. We'll see what happens. What were some of the other things?
And the final question was about Google.
Oh, what can Google do?
So let me phrase it. You're well familiar with Google's activities so far. RE less than C, our power meter work, those things. Obviously, we care a lot about your agenda, the things you care about. What are some things you'd like us to do? Where are we best aligned with the strategic mission of the Secretary of Energy?
Well, I think first, you're the search engine that enables people to get information. I think this company has set leadership in its concern about trying to make its servers and all the equipment associated with the internet much more energy efficient. And so I think you should keep up in the leadership position to drive those technologies. The renewables less than coal is something where, it's great. When you first announced that, I was thrilled by that. Companies like Google that showed leadership in where, this is an incredibly serious problem. And more and more companies, large companies who get on board, in small companies, they get on board and say, we have to make this part of our business plan. And also realize that there's an incredible opportunity, as I said in my press conference. China is moving very aggressively. They see the new industrial revolution, a green industrial revolution, as part of their economic future. They want to lead in this, in all aspects, in solar, in wind, in electricity transmission distribution, in energy efficiency, in buildings. that's part of their business plan in order to be continue to grow as an economic giant. But I go back to this. Google's an excellent example. If you set the conditions right, for example, a cap and trade program, the proper stable tax incentives, the proper support of the research that the private sector is not willing to pick up, and you set these conditions right, the United States can blow any other country in this. We can do it better than anyone else can because it's this entrepreneurial, inventive spirit that is so good in the United States. And so just keep up what you're doing and in your leadership on reducing your carbon footprint and all the things you're doing. It's great.
Well, I think you all have seen why Steve may become one of the most influential scientists of our generation if he already hasn't at the scientific level. First, as a scientist, one of the most brilliant scientists in physics we've had, then foolishly becoming an administrator, running everything, and now running the entire science agenda for much of what we care about. Steve is one of my heroes. I'm really, really glad you were able to come to Google today. Thank you very much.
Thank you.
Thank you.